All right, we are going to go ahead and talk about the periodic table of elements. So we know the periodic table is a table where elements are organized by increasing atomic number. We talked about that already, where you know that the very first element listed on the periodic table has 1 proton, and the next one has 2, and 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. And then something you may not know is that the table is arranged by groups and periods. So here's the periodic table, okay? They're arranged by groups, okay, and periods. And I'll show you what those look like in a sec. So groups. Each column is called a group. They are vertical, okay, and they have similar properties. So all these guys here have the similar properties, as all these as everyone else in the group, and then all these guys here have similar properties, all these guys here have similar properties as each other, all these guys here have similar properties of each other, so on and so forth. So here, each group is going to have the same amount of electrons. So this first group right here has 1 electron, this second group has 2 electrons, this one has 3, this one has 4, this one has 5, this one has 6, this one has 7, and this one has 8. And if you remember, an atom has 8 electrons in its outermost shell unless it is hydrogen or helium. So look, we can figure out how many electrons an atom has by counting what group it's in. So it's either 1, 2, 3, 4, 5, 6, 7, or 8. Now all these guys in here, okay, they change out their electrons, and there are different versions with different numbers of electrons in them. So we don't really count them. But definitely group 1 and group 2, 3, 4, 5, 6, 7, 8, okay, are all, or excuse me, I guess 18, this would be 18, are all going to have that many electrons. So group 1, group 2, this is going to have 3 electrons, 4 electrons, 5 electrons, 6 electrons, 7 electrons, and then 8 electrons. Okay, periods. So the periods are the rows that go across. Each row is called a period. They're horizontal, okay, and they go increasing number of protons. So 1 proton, 2 protons, 3, 4 protons, 5 protons, 6 protons, 7, 8, 9, 10, 11, 12 protons, 13 protons, 14 protons, and so on and so forth. Each row in the periodic table ends when an outer level energy is filled. So in other words, if you remember when we just looked at these and we said this had 8 electrons, that means its outermost shell is filled. The valence electrons has as many valence electrons as possible. That means a new row starts once the outermost shell is filled with 8 electrons. So 1 electron, 2 electrons, 3, 4, 5, 6, 7, 8. Now we're going to start a new period, and this one has 1 electron, 2 electrons, 3, 4, 5, 6, 7, 8. Now we're going to start another period. And the elements in each period have the same number of shells. So these guys right here have 1 shell, these guys have 2 shells, these guys have 3 shells, and these guys have 4 shells, and so on and so forth. So now we can kind of get a good idea of what the element looks like, as I've said before, by looking at its location on the periodic table and by looking at the actual element itself. So each of the energy shells can hold a maximum number of electrons. So remember, if it's level 1, it's going to be 2 electrons. That's the only level of, or shell of electrons that only holds 2, and every single element is going to have those 2 electrons. Or I guess not every single element, but those first 2, hydrogen has 1 electron in the 2 shell, and helium has 2 electrons in the 2 shell, and then we start another period because that's the outermost shell. Every other element will have an outermost shell of 8, and that means that would be, we can determine what the outermost shell or the valence electrons look like using this thing called an electron dot diagram. So here we have helium, and you will notice that helium is over here, okay? So 1 electron, 2 electrons. That's why there's only 2 electrons in that first shell. See? 1, 2, and then the 2's filled, so we start a new period. So this one has 2 electrons in its outermost shell. So you'll notice that helium in our dot diagram has 2 dots on it, one for each of the electrons in its outermost shell. Now we're going to do oxygen. So oxygen is going to have its first shell of 2 filled, and then it's going to have 1 electron, 2 electrons, 3 electrons, 4 electrons, 5 electrons, 6 electrons in its outermost shell. So if you look, we've got 1, 2, 3, 4, 5, 6 electrons. The next one is neon. So we find neon, here it is. It's going to have this shell filled, but the outermost shell is going to be this row. And it's going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So that means that it's going to have 1, 2, 3, 4, 5, 6, 7, 8 dots. Now aluminum, okay? Aluminum is right here. So that means it's going to have the shell with 2 electrons filled, the shell of 8 electrons filled, and now we're going to be in this period right here. And that means it has 1, 2, 3 electrons. So if you look back, 1, 2, 3 electrons. So you can just look at where it is. You can see how many shells. So if you look back here, we can look really quickly, and we see that depending on where it is, it's going to tell you the number of shells. So 1 shell, 2 shells, 3 shells. Well, aluminum is right here, so we know it's 3 shells. The first one always has 2, a max of 2, and then every one after that is going to have 8 in its last electron shell. All right, so now the groups. So this is broken up into very specific groups in the periodic table. We'll start with metals. So metals are good conductors of heat and electricity, but all mercury are solids, metals are solids at room temperatures. That should say metals are solid at room temperatures. Metals are located to the left of the stair step. So if I look here, you see how there's this stair step. Okay, all of these elements to this side are all going to be metals. Okay, all of these are going to be metals. Within the metals group, we have alkali metals. That's in group 1. So that's going to be this very first group right here. And the alkali metals are most reactive, and they don't really occur in nature. So they're usually bonded to something else. And we'll talk about bonds in a little while. And then we have the alkali earth metals. This is group 2. They're shiny, ductile, meaning they're bendable and malleable. And they combine readily with other elements. So this is group 2. So all these guys are the alkali earth metals. And then we have these other metals called transition metals. They're right here. And they are everything that they don't really fit into a category, but they definitely are all metals. And in here you're going to find things like silver and gold and copper and cobalt, all those interesting things. Zinc and tin is all in there. So, okay. Non-metals. So we have our metals, and now we're going to talk about the non-metals. So we have intertransition metals. They are listed below the table, and there's the lanthanide series. These are the elements that are 58 through 71, so the first row, and then actinide series, or the second row. So here, the lanthanide series and the actinide series. And then we have nonmetals. These are elements that are usually gases or brittle solids at room temperature, meaning they can be broken. Most can form ionic or covalent compounds, meaning they can form bonds, and they are located to the right of the stair step. So here's our stair step again. Okay, so all of these guys are going to be your nonmetals. So there's a lot more metals than nonmetals. And then we have a group within the nonmetals called the noble gases. And they are isolated atoms, meaning they don't bond because their very last shell already has 8. So these are your noble gases, and if you remember, 1 electron, 2 electrons, 3, 4, 5, 6, 7, 8. And if it has 8 electrons, it's not going to want to react. So all of the noble gases all have 8 electrons. And that means they don't really want to react with anyone else. They are lone atoms. Okay, and finally we have the metalloids. Metalloids are elements that make up the stair step. So that stair step we've been talking about the left or the right of. These metalloids have both metallic and non-metallic properties. Metalloids are part of the mixed group, which contain metals and nonmetals, and they are part of groups 13, 14, 15, and 16. So all of these guys right here, 13, 14, 15, and 16. So these are all your metalloids, okay? And they have characteristics of both metals and nonmetals. They're kind of the in-betweeners. So yeah. And here's a good rundown of what everything is. And you can kind of take a look at that. Poor metals just means they don't really have the characteristics of either, so they're like the metalloids we talked about. Transition metals, lanthanides, actinides, alkali and earth metals, and the alkali metals. And we're going to talk more about what atoms look like with dot models soon. All right, thank you very much.